Bonjour and welcome to my video this week. Sorry for the delay, well basically 2 months. It's because I had the mocks and I had to revise quite hardly. Anyway, today we'll be covering the last the last unit in chapter 1, which is Rationalising Denominators. Firstly, you may have done this in GCSE, most likely, but as a recap, for the first question, here is a surd, root 3. What number should we use to multiply that there is no longer an irrational number, i.e. root 3. In this case, the number would be root 3 to give us 3. The second one, to rationalize a denominator, is the same as making the denominator into a rational number, i.e. removing the surd. In this case, we'd have to multiply the denominator and the numerator by root 5. Because whatever you do to the bottom, you do to the top. And we should get root 5 over 5. Here are some examples you could try. Please pause the video and try the questions. So, for the first question, you should have multiplied the numerator and denominator by root 2. In which case you should have got 3 root 2 over 2. The second question, if you're going down, you should have multiplied the top and bottom by root 3, which you should get 6 root 3 over 3. You can simplify this fraction by removing the 3 and getting 2 root 3. For the third question, you should multiply the top and bottom by root 7, which you should get 7 root 7 over 7, and you can simplify it to get root 7. The bottom question, rationalize the fraction by multiplying the top and bottom by root 5, which you should get 20 root 5 over 5. Simplify it to get 4 root 5, add the plus root 5 to get 5 root 5. For the top right question, you should multiply the top and bottom by root 3, then simplify it to get 4 root 3. The next question, you should get 2 root 6 over 6. Simplify it to get root 6 over 3. The last question, you could multiply the top and bottom by root 8, but if you notice that root 8 can be simplified even further into a surd of 2 root 2, you can simplify the fraction to get 2. Or if you had a complicated denominator, rather than just a surd, you had, in this case, root 2 plus 1. You would multiply the top and bottom by its conjugate, which in this case would be root 2 minus 1. As it's shown at the bottom, a plus b multiplied by a minus b would give you a squared minus b squared. Using this fact, we use the conjugates of both forms to get a rational number. And in this case, it's root 2 plus 1 and root 2 minus 1, which should give you root 2 minus 1 at the end. Have a go at these questions. Firstly, you should multiply the denominator by root 3 plus 1 to remove the surd. We should give you 3 root 3 plus 3 over 2, as it's shown in the box. Second question, we would multiply the bottom and top by root 3 minus 1 to give us 2 root 3 minus 2 over 2. For the last question, you do the exact same and multiply. You can simplify the second question into root 3 minus 1. For the last question, you can multiply the top and bottom by 5 root 2 over plus 7 to give you that. Simplify that fraction to give you 58 plus 41 root 2. Here are some more questions to answer. For the first one, this is the answer. Multiply the top and bottom by root 5 plus 2, which should give you 4 root 5 plus 8 over 5 minus 4, to give you 4 root 5 plus 8. For the second question, multiply the top and bottom by 3 root 3 minus 1, to give you that. which should give you 19 minus 5 root 3 over 26. Writing third expressions in power form. This is not shown in the textbook, but it's very useful to know, as in differentiation and integration, which is chapter 11 and 12, I believe. It's going to be used quite a lot. So the first question on the left, here's what you do. You expand the top bracket. You turn every third into a power of x, which in this case, 4 root x would be 4x to the power of a half. You split the fraction, which I technically recommend, as it's especially useful when doing integration or differentiation, which should give you 4x to the power of minus 1 plus 4x to the power of minus a half plus 1. For the second question, this is what you should have done. Have I got this extension question? Please pause the video. So firstly, you find the conjugate of the denominator, which in this case is root a plus 1 minus root a. And it should give you this very long expanded version, which should simplify to this. And it should give you this, which is 2a plus 1 minus 2 root a times root a plus 1. Finally, have I got this extension squared question? It isn't very hard. Just turn the numbers into a form of 3 to the power of something. And the laws of indices are on the right, in case you forgot. So this is the answer. So firstly, we turned 9 and 27 into powers of 3, which is 3 squared and 3 cubed respectively. Fourth rooting and fifth rooting can be written as a fraction, when in this case is a quarter and a fifth. And then once we multiply the bracket, we should get 3 to the half divided by 3 to the 3 fifths, which, if we use our laws of indices, we should get 3 to the power of minus a tenth. And as x rooted 3 is same as 3 to the power of 1 over x, 1 over x is equal to negative 1 over 10, which in this case x equals minus 10. Thank you for listening to this video. Please subscribe, like and comment, and hope you have a good day.